Hello, in today's video, we will understand how the nuclear tragedy of Hiroshima revealed clues about the formation of the solar system. It all began in August 1945 when the United States dropped 2 atomic bombs on the cities of Hiroshima and Nagasaki in Japan. The tragedy devastated the region and killed over 140,000 people. But it was not only devastating because of these hundreds of thousands of deaths, but also because of the lasting impacts to this day, particularly the high incidence of radiation-induced cancer. The immense destructive power of these 2 atomic bombs was evident in the destruction they caused, stemming from a sudden release of energy produced by the splitting of the nuclei of the physical elements comprising their cores. 2 types of atomic bombs were developed by the United States during World War II. The first, called Little Boy, was a gun-type weapon with a uranium core. This bomb was dropped on Hiroshima. The second weapon, dropped on Nagasaki, was called Fat Man and was an implosion-type device with a plutonium core. 70 years later, scientists discovered debris from the nuclear explosion in the form of glassy spheres scattered along the beach of Motujina, a small island in Hiroshima Bay. Scientists proposed that the concrete and steel that once composed the buildings of Hiroshima were whipped and burned in the extreme heat before cooling and falling back to Earth as rounded spheres, similar to glass. The interesting aspect of this discovery is that the formation of primitive meteorites has a similar process. This information was published in a study in the scientific journal Earth and Planetary Science Letters, demonstrating that the explosion of these 2 bombs may have helped solve some of the great mysteries about the formation of the solar system. There is a type of meteorite that developed in the solar system through cosmic dust and nebula gas, called chondrite. The research indicates that the formation of glass is analogous to these cosmic objects from an early period of our stellar system, as, like chondrites, the so-called Hiroshima glass is formed through condensation within the nuclear fireball. To understand how the samples were created, researchers conducted simulations reconstructing the conditions of the Hiroshima explosions. Thus, by studying 94 nuclear bomb debris, they found 4 types of glass: melilite, anorthosite, soda lime, and silica. Chemically, the silica glass seemed identical to quartz sand grains found on any beach, and the soda lime glass resembled industrially made glass. However, all 4 types of Hiroshima glass had very peculiar compositions of oxygen and silicon isotopes, giving researchers a new way to study how they might have formed. The team conducted simulations reconstructing the chemical composition and physical conditions of the nuclear explosion based on previous research, using these estimates to model possible condensation processes within the Hiroshima fireball. Previous research had estimated that the Hiroshima bomb exploded 580 meters above the city, far above the surface to leave a crater. However, temperatures were very high, reaching 10 million degrees Celsius within the fireball itself and about 6,000 degrees Celsius on the ground, vaporizing the building materials in seconds. The spheres found were similar to other common small glass pieces, but further analysis highlighted that the oxygen and silicon isotopes were different from what is normally expected. The team's simulations revealed how melilite liquids first condensed from the gas cloud in a process known as fractional condensation, followed by anorthosite, soda lime, and silica liquids. These droplets then turned into glass, when exposed to temperatures between 1,800 and 1,400 degrees Celsius depending on their composition. If you are enjoying this video, please click the like button. We still have few subscribers, and your like, along with your comment and subscription, will help improve the development of the texts and the editing of the videos, making everything even more interesting. Write your impressions and suggestions in the comments. But back to the subject. The chemical reactions during the condensation of Hiroshima glasses are probably the source for the independent mass fractionation of oxygen. Although researchers are also intrigued by the prospect of observing the beginning of the solar system through what happened in Hiroshima, they recognize that the pressure, temperatures, and gas mixtures differ greatly between the Hiroshima explosion and the solar accretion disk, where chondrites first formed. During the explosion, the temperature, which rose to 10 million degrees Celsius in the fireball and about 6,000 degrees Celsius on the ground, sharply dropped in 10 seconds and halted the vaporization that was occurring. The high pressure caused by the bomb also ceased and returned to equal that of the atmosphere within 35 seconds. The study suggests that understanding the gas-to-solid transition process can help uncover some mysteries about the beginning of the solar system. and it concludes that these isotopic compositions are understood as a result of their formation by condensation in the nuclear Cloud of Hiroshima at high temperatures. Hiroshima glasses provide a better understanding of the processes that occurred during the Hiroshima explosion and its consequences, its mode of formation, and its isotopes. Other studies related to Hiroshima glasses continue to develop, trying to clarify some of the remaining doubts about the beginning of our solar system. They are small pieces of an immense puzzle, but little by little, we are discovering pieces that fit into solving this mystery. I hope you enjoyed the video, and don't forget to subscribe to receive other increasingly interesting videos and to comment on your impressions, criticisms, and suggestions. Until next time.